I just need a recording phone and a phone. So how's this going to look? This is going to be weird. It just is. This is what's called a construction proof. So here in glorious detail, here is the idea. So if I want to prove the limit as x goes to a, I'm trying to use the same notation I used, yes. We have to show, given epsilon greater than 0, that's the distance away from the limit on the y-axis, we must find delta greater than 0 such that if I am that close to my input, then I am as close as they want me to be to the limit. Somebody tells me how far they need me to be from that limit number. I then figure out what delta has to be so that I'm always that close to the actual limit. Now really quickly, we talked about absolute values means distance, yes? So this literally, I could read this as the distance between a and x is at most delta, or less than delta, and the distance between the limit and the function value is less than epsilon. So that's why those are distances. Okay. The actual work for this, again, it's all right. Let's try a problem, Jeff. Okay. It's going to feel like we're cheating a little bit. Prove the limit as x goes to, what should I start with? It doesn't matter. Okay, x goes to 2 of x squared minus 4 over x minus 2 is 4. Now, we're obviously going to start with stuff that's relatively easy. I need to say this. The epsilon delta approach, which is what this is called, this is the epsilon delta approach, gets exponentially more difficult the minute my functions get any level of weird to them. So we normally stick with things that either reduce to or are lines. Do y'all agree with me that that reduces to a line? X plus 2, yes? The minute it's something that is actually truly parabolic or something, the level of difficulty goes way to shit up. Okay. I love you guys. Okay. So in order to prove this, we want to show that given epsilon greater than 0, we can find delta greater than 0 such that if x minus 2 is less than delta, then f of x minus 4 is less than epsilon. So if I'm close to 2, my inputs are close to 2, my outputs are close to 4. That's what that says. In very formal language, but that's all that says. And that's where we started this whole discussion, was interpreting limit statements as get close to this, your outputs get close to that. Yes? So here's the weird part. This is what's called a construction proof. Fundamentally, what I need to do is, if somebody gives me epsilon, I have to figure out what delta is. So the proof constructs what delta has to be. That's why we call it a construction proof. So here's what's really, really weird about this. I start where I want to end. And that's why it feels weird. We're going to do what's called side work. Not a side hustle, I'm sorry. We're not going to make any money. Side work. So I start with where I want to end. I want to be here. Yes? I want that. Isn't that where I want to end? f of x minus 4 is less than epsilon. I want that to be true, yes? You guys all with me? Screw you, Jeff. All right, simplify this. What did you guys tell me this divides to be? X plus 2 minus 4. And what's x plus 2 minus 4? For the problems I've assigned to you, besides maybe one that I try to give you to push you a little bit, they're almost all going to work out exactly like this. Do you guys, I need you to see what just happened. What has got to be true about our delta? What statement is our delta in? What's got to be true for our delta? No. I mean, not from what we did, but just in general. X minus 2 has to be less than delta, correct? But what did we just figure out? If somebody gives us an epsilon, what must be true about x minus 2? Absolute value, it's got to be less than epsilon. So what do we choose our delta to be? Freaking epsilon. So if I would have gotten a 2 epsilon here, I would have let delta be 2 epsilon. If I would have got epsilon over 3, I would have let delta be epsilon over 3. You guys see that? Given an epsilon, I can figure out what my delta has to be based on that to always make this true. So then I'm not like reacting. Somebody says 0.1, I'm like, well, let me make something. And then somebody like 0.01, then I gotta make something. No, I'm gonna make something for whatever the shit epsilon anybody can give me, and then it's true. So that's the side work. So now I know what I want delta to be. Given epsilon greater than 0, we must find delta greater than 0. Did we? Yeah, what do I want delta to be? So here's the proof. Let delta equal, what did we say? Why do I want delta equal epsilon? Because if I let delta equal epsilon, this will actually work. Let delta equal epsilon. Then, if x minus 2 is less than delta. Now listen. Let me see. I know some of you guys are tripping right now. We're talking about epsilon, delta. It's just too much Greek shit, Jeff. What are you talking about? Give it the Lord. You know Greek comes up in every math class just about at some point. Either it's an old Greek dude, Pythagoras, or it's Greek letters, yes? This is almost too simple once you do it a couple times. And that's why I only assigned a few of these. It's not that big of a deal. To me, the most important part about this section is to solidify the formal definition of limit. And if you go through this, future stuff we do references delta and epsilon, and then I can say, hey, remember that shit? We did that shit. Right? Some semesters I have to skip this section, and it kills me a little bit, because then I know later in the semester I can't say as much as I wanted to. And you're all like, you could have skipped it, Jeff. We would have been okay. Shut up. So if x minus 2 is less than epsilon, that's awesome, less than delta, look what I can do. If this is true, isn't this true? Isn't that true? I'm sorry, and we let delta equal epsilon. I should have done that up here. Yes? And then isn't this true then? Isn't x plus 2 equal to this? I mean, look what I'm literally doing. I'm just doing this backwards, yes? So somebody gives me epsilon. I'm given epsilon. I let delta equal something so that this leads to this. So did we just make it there? This is my f of x. Done. Therefore, the limit as x goes to 2 of x squared minus 4 over x minus 2 is 4. If somebody gives me an epsilon, I can always find a delta so that if I'm this close to 2, I am that close to 4. That's all that says. I love you. So let me give you this handout that just has another example for you. And then it's got a problem. I want you guys to try it on your own. Or, with people. That's fine too. So I gave you a fully worked out problem with all the side work. Shabba-dabba-dabba-da. So I want you to try to do this one. Go for it. That's pretty good, yeah. Do it again.
Why'd you get like a GoPro?
No, I'm
I
sorry.
already get two things going on.
Well, yeah, but like
My
with
phone's
the
always
verification
busy.
thing,
Huh?
with the verification thing,
Have
you get
here,
verification.
put the target over here.
That hardly ever happens.
You unify this and multiply.
It's all good. I appreciate it. Yes.
So you're here, right? So you're right here, so you normally divide by 2. Then on the part. So 10 is the same thing as.
So you have to say.
Yes, this is supposed to be negative.
That close on the x-axis, become that close.
This is where we ended up. Wait, how did you, did I cross out the wrong thing?
All right, guys, let's see here. Side work.
Correct. And then you multiply the 2 and you get, how did you get this
So then if I simplify this, this becomes 2x plus 10, yes?
this minus.
Is that cool? Yes. Minus 20, which is 2x minus 10. And if I divide by 2, which I'm allowed to do because it's positive,
So that's your
so I'm going to show you a visual of this here in a minute. But if I get that close for my inputs, my outputs will always be within epsilon of the limit. That's what we just got. So given an epsilon, can we find a delta? Yes, what do I need delta to be?
Our delta has to be greater than the absolute value of x minus 5, right? Because we have to follow.
But what do I want it to be? I now know what I want to let delta be.
Yeah.
Yeah. Given epsilon greater than 0, let delta equal to epsilon over 2. Then, if x minus 5 is less than delta, which is epsilon over 2, then I just start, this is where it feels like you're cheating. You just start doing this backwards. If I am this close on my x-axis, then I start to develop what's happening on the y-axis. Where'd it go? There it is. Ooh, I forgot to, oh, you're smart, Jeff. So if I multiply both sides by 2, there we go, buddy. So this should just be epsilon, there it is. 2x squared minus 50 over x minus 5 minus 20 is less than epsilon. So if I am this close on my x-axis, that leads to me being as close as they wanted me to be from the limit on my y-axis. So it's a challenge somebody's given me. I want you to be this close, and I'm like, all right, I gotta find a delta. So if somebody wanted to be 0.1 away from the limit, we would be 0.05 away from our input. And that would make me, in fact, let's do that. Let's do that. Look how excited I am. Do I have time? Yes. Guys, is everybody semi-okay with that? Yes?
So, once we do the math for the side work, we just write.
Once you do the math for your side work, you're basically done.
You just bring it down.
Yes, but write a little bit of the proof. Given epsilon greater than 0, I let delta be this, and then you just basically write what you did backwards.
Okay.
That's the part that feels like you're cheating. But you're not cheating because you did a lot of work to get there. So the proof doesn't have anything to do with the side work. The side work is us constructing the delta that makes it work. So, two things. Guys, watch this. So let's say somebody wanted me to be 0.1 away, yes? Yes? Guys. Somebody wants me to be 0.1 away in this problem. You with me? Okay. What am I going to let delta be?
0.1/2.
Yeah, 0.1/2, which is 0.05. Yes? You with me? That's the distance I am away from what? That's the distance what is from what? Oh boy. That's the distance my inputs are away from 5, correct? So what's the lowest input I could use? So here's 5, and I want to go up and down by this much. Is that cool? I'm making a little neighborhood around my input. So if somebody gives me epsilon as 0.1, I'm going to let delta be 0.05. That's how far up and down I want to go away from 5. You with me? Now, somebody help me out. This would be 4.95 and 5.05, yes? Can some of you guys figure out the value of this for 4.95? And some of you guys figure out the value of this for 5.05. Let's concretely see if this shit works. This weird ass shit that you're making me do over my summer, the second day of class check. What the hell? Greek shit. What country is that? That's what echo when they think it's happening. Somebody said out there. I thought it was in America. Be really careful when you plug it in your calculator, because it doesn't have eyeballs, right? So you got to tell it this is the top, this is the bottom. So is anybody doing 4.95? Is anybody doing 4.95?
I got 19.9.
Yeah, 19.9. And for 5.05,
20.1.
20.1.
Just plus or minus 0.1.
And 20 is supposed to be the limit, correct? So sure enough, if I make delta 0.05 for my inputs, I want to be away that much, that makes my outputs at most 0.1 away from the actual limit. You guys, that's the concrete other side of what the shit we're doing. So somebody else came along and says, I don't want epsilon to be 0.00. I'm like, just divide it by 2, plug it in, leave me alone. We already did every epsilon. Yes? Maybe? So here's even better. Homework problem. I can't remember which one I assigned. So look at this one. They don't tell me what the function is, but they want me to be within 0.2 of 1. You guys see that? Now watch this. If I follow this over, that's an input of 0.7 gives me that, and that's an input of 1.1 that gives me that. Yes? How far away from my input of 1 is this? 0.3. How far away from it is this? Now, do you see how delta can't be two different things? It's the amount that I go up and the amount that I go down. Yes? I want to make delta the number such that every input within that far ends up this far away. So I want it to end up in this little box here. I can't let delta be 0.3 because if I go to 1.3, I'm going to end up in the little box. No, it looks like 1.3 is going to be ending up like way that shit down there, yes? So does it make sense then? I'm going to let delta be the smaller of the two. Because if I just go this far, I'm even better. I'm even closer than I needed to be, yes? So this is a visual of what we're doing. Somebody says, I want you to be this close. I go, oh, I got to be this far away. And let me pick the smaller one so that I'm always at least that close. I actually made it even better, but it's better than making it worse. So always pick the smaller distance. Maybe. And I don't think I signed too many out of that section. Some of you guys are cool with that, and some of you guys are like, oh, come on, these aren't that bad. Okay. Yeah, okay, this is perfect. This is fine with me. I'm okay. So what we'll get into tomorrow is we'll get into continuity. I sort of already did get into continuity a little bit. For example, I'm pretty sure you guys could just tell me where this function is discontinuous. We're gonna get into more the definition of continuity, the types of discontinuities. So I talked about jump already, and I talked about removable. So let's do this. We're gonna go on a little field trip. Very quick, we're not going very far at all, yes? Can you guys all do me a favor? Walk out the door and go very slowly that way. Very slowly, and then let me run out in front of you and I'll take us where we gotta go. Okay. It's gonna take me a minute to pack up.